Hello students, in the today's video I am just going to distinguish between rectilinear and curvilinear motion of a particle. A particle performing motion may be subjected to a single or number of forces. In case it is subjected to number of forces, what we do is that we reduce the given system of forces into a single force, and which is called as the resultant force. Being a vector quantity, resultant force has got magnitude as well as direction. Now the magnitude of this resultant force and the direction of the resultant force may remain constant or it may change. Depending upon whether the magnitude and directions are constant or varying or changing, the type of motion can be discussed. So here I have prepared one table, and with the help of this table I am going to discuss the type of motion which the particle is going to perform. Now here in this first column I have written force. Now this force means the resultant force. Now the force can have magnitude as well as direction. So there are two sub columns over here, and the type of motion I am discussing it in this column. Here the force, when its magnitude, the magnitude it may be 0, means there may not be a force acting on the particle, and it's as the force is not there, the question of direction will never be there. So if there is no force, the body or the particle may be at rest, or it may perform a uniform rectilinear motion, which can be explained with the help of Newton's first law. The body or the particle continues to be in a state of rest or state of uniform motion unless acted upon by an external force. So no force is acting, the particle may be at rest, or it may perform a uniform rectilinear motion with constant velocity. Second case, the magnitude of the force it is constant and direction is also constant. So both are constant. In such case, the rectilinear motion is possible with constant acceleration. As force is constant, the acceleration is going to remain constant. As the magnitude of force is constant, magnitude of acceleration is constant. As the direction of force is constant, the direction of acceleration is also constant, and such a motion is rectilinear motion with constant acceleration. Case number 3. Now I am considering that the magnitude is not constant, it is changing. So if the magnitude of the force is changing continuously and its direction is constant, the body or the particle still remains in rectilinear motion, but the acceleration will not be constant, it will be variable. So in case if the magnitude is changing, the direction is constant, the particle will perform rectilinear motion with variable acceleration. The next case, in this case I am considering the magnitude as constant and direction is changing continuously. If the magnitude of the force is constant, it is obvious that the magnitude of acceleration will also remain constant. But as the direction is changing continuously, the particle will be put into uniform circular motion. So it is a case of uniform circular motion. The direction of the force is changing continuously, whereas its magnitude is constant. The next case, the magnitude is changing and the direction is also changing continuously. So if magnitude and direction both are changing, the motion of the particle will be a curvilinear motion. So this is how the motion can be defined depending upon the magnitude and direction of the resultant force acting on the particle. So for rectilinear motion to happen, what is important is that the direction of the force acting on the particle has to be constant. So direction, if it is constant, the body or the particle is definitely going to perform a rectilinear motion. Whereas if the direction is changing continuously, then the particle will be put into a curvilinear motion. So if the direction is constant for the force acting on the particle, then the particle will be in rectilinear motion, and if the direction is changing continuously, the particle will definitely be performing the curvilinear motion. But there is one exception. If the particle has some initial motion in a direction which do not coincide with the direction of force, in this case also, even though the direction of force is constant, but if the particle has some initial motion in a direction which do not coincide with the direction of force acting on the particle. In such case also the curvilinear motion is possible, which is a special case of curvilinear motion and is called as projectile motion. Now it can be discussed with the help of an example. Suppose there is a stone, and if it is thrown along a certain direction other than vertical. So if I throw a stone along a certain direction other than the vertical, the stone is going to perform a curvilinear motion like this, and which is called as projectile motion. Now if we observe this motion, we can see that at every position the direction of force is constant, its magnitude is also constant. The direction of force is vertically downwards at every position, whereas its magnitude is also constant. Still this particle is performing projectile motion. It is only because it is thrown with some initial velocity. So it has some initial velocity, and the direction of this initial velocity is not coinciding with the direction of the force acting on this particle. As such, it performs a projectile motion, which is also a sort of curvilinear motion. So it is a special case of curvilinear motion. So remember it well. A particle is going to perform rectilinear motion if the direction of the force acting on the particle remains constant, whereas if the direction of force is continuously changing, then the particle will be performing a curvilinear motion. There is one more type of translation motion, which is called as oscillatory motion. So in case of oscillatory motion, the magnitude of the force is continuously changing, whereas its direction changes periodically. So that is called as oscillatory motion. So this is how you can distinguish between the rectilinear and curvilinear motion. Thanks.